students, I hope all of you are doing good. Let's start today's chapter, Symmetry. After reading this chapter, you will be able to know about all these topics. So let's get started. Introduction. In class 6, we have studied about the line of symmetry, which is also known as a reflection symmetry. A figure is said to be symmetric if it can be folded about a line in such a way that the two parts formed will coincide with each other. The plane mirror produces an image of the object which is of the same shape and size but in opposite essence, that is later inversion. This is called reflection. In reflection symmetry, mirror is the line of symmetry. Okay. Lines of symmetry for regular polygons. A polygon is a closed figure bounded by several line segments. The polygon made up of the least number of segments is triangle. A polygon is said to be regular if all its sides are of equal length and all the angles are of equal measurement. Thus, an equilateral triangle, a square are both examples of regular polygons. For a regular pentagon, all its sides must be equal and each angle must be of 108 degrees. All the regular polygons are symmetric figures and can have one or more lines of symmetry. For example, an equilateral triangle has 3 lines of symmetry, as you can see in this picture. A square has 4 lines of symmetry, right? A regular pentagon has 5 lines of symmetry. You can also verify all this by paper folding activity. Now look at the figure A and B. Okay, see, this is the line of symmetry. Okay, and this line is not the line of symmetry. Okay, so do you agree that dotted line is not the line of symmetry? In figure A means this one. Okay, and because if we fold the figure along the dotted line, the two parts are not mirror image of each other. But if we draw the line as shown in figure B, this one, then clearly the two parts are mirror images of each other, and hence L is the line of symmetry for the given thing. Now write all the letters of English alphabets in capital and try to draw their lines of symmetry if possible. How many letters have no line of symmetry? Find it out. Okay. Exercise 14.1. Draw the following figures and try to find the line of symmetry with respect to the dots marked on each figure. Okay, student, this is really very simple. You can do it. What you have to do is you have to find the lines of symmetry with respect to the dots, okay, which are marked on the figures, right? Next, rotational symmetry. There is another kind of symmetry than line of symmetry. It is called rotational symmetry. Look at the given figure given above. Does it have a line of symmetry? No, but it can be rotated in some way that we get the same shape. Observe the rotation of the figure about the angle marked 90 degree at O. Rotational symmetry is also called radial symmetry. Remember that. Okay. Maths extension. Rotational symmetry is also called radial symmetry. Number 2, line of symmetry term is used in reflection symmetry. And number 3, point of symmetry term is used in rotational symmetry. These figures show a sort of regularity discovered by rotation. They are said to have rotational symmetry. The point about which these figures have to be rotated to discover this type of regularity is called center of rotation. The figure above made 4 moves before it is back in its original position. Thus, it is said to be rotational symmetry of order 4. Okay. A figure given below has no rotational symmetry. This one. Okay. Copy the figure given above and choose any point of the plane as the center of the rotation. Try to rotate the tracing about the point so that it falls into the figure again. This is possible only by one full turn. Such a figure is said to have rotational symmetry of order 1. Given below are some figures with various orders of rotational symmetry. Okay. Order 1, order 2 means if you rotate it by 2 times, you will get the same shape again. Order 3, order 4, order 5 and order 6. Okay, no more. A figure is said to have rotational symmetry about point O if rotating it about O, it fits its outline at least once before it has made a complete turn. O is called the center of rotation. Number 2, the number of times the shape fits onto itself in one turn is called order of rotation. Number 3, the smallest angle you need to turn the shape to fit into itself is called angle of rotation. Example, in this figure, angle of rotation is 72 degree and order is 5. Okay. No more. The point to be remembered here is that a figure with rotational symmetry of order 1 is called a figure with no rotational symmetry. Right? Example 1, for each of the following figures, copy the figure. Number 2, mark the appropriate center of rotation. And number 3, state the order of rotational symmetry. Okay. See, if we look at figure A, it has a rotational symmetry of order 2 and the center of rotation is midpoint of BC. Okay, BC. This is the BC and this is the midpoint. Okay. And figure B, this one has a rotational symmetry of order 3, center of rotation is O. And figure C has a rotational symmetry of order 2, center of rotation is O. Okay. Now, location of the center of rotation. When the rotation is of 180 degree, the center of rotation is the point of intersection of two line segments joining two opposite points. For example, triangle ABC is rotated through 180 degree and its image is, as you can see here, its image is what? Triangle A dash B dash C dash. Joining A dash and C dash, the point of intersection is what? This is the point of intersection, that is O. This O is the center of rotation. B, when the rotation is other than 180 degree. Under the rotation of other than 180 degree, the center of rotation is the intersection of the right bisectors of the joint of two objects points with the corresponding image points. In the figure, A dash B dash is the image of AB. The right bisectors of A dash and B dash intersect at O. Thus, O is what? Is the center of rotation. Okay. Exercise 14.2. Number 1, for each of the following figures, mark the approximate center of rotation. Number 2, state the order of rotation symmetry. Okay. So in these figures, what will you do? First, you will mark the approximate center of rotation, and then you will find out how the order of rotational symmetry. Okay. There are many geometrical regular figures like different kind of triangles, quadrilaterals like parallelogram, square, rectangle, and polygons of more than 4 sides, circles, etc. Out of these all, some have a rotational and reflection symmetry, but some figures have either only rotational symmetry or only reflection symmetry. Okay. Exercise 14.3. Number 1, name any 3 figures that have both line symmetry and rotational symmetry. Well, you can easily write the name of 3 figures, and the figures are square, rectangle, and rhombus. Okay, students, now you will do practice of this chapter and this exercise also.